So another major issue in network layer is a packet loss. Okay, so that actually like affects the performance of the communication. It's like during the number of during the transmission due to noise, or it can be due to various issues, uh, the packets will be lost, right? So that packet loss severely impacts our communication, right? So the effect of packet loss in the internet layer, the packet needs to be resent, which in turn may create overflow and all that stuff. Okay, more and more packet loss.
Yes.
So basically, congestion, I said, like when it will happen. One is due to throughput. I mean, like if the throughput amount of data which I can transmit, that is like limited. Then another is delay. If the packet is delaying in between any path, then at some point, some node congestion will happen, right?
Yes. Yes, sir.
So if you see here, I have this load actually. Okay, this is the capacity. So if you see here, this is the maximum capacity. So if you keep on
Yes.
increasing the data, then it will actually so if you see here, like at this point congestion happens. So whenever congestion happens, your delay will increase because I have to queue that data, right?
Yes, sir.
Yeah, so more the congestion, basically delay will happen. Okay.
Yes, sir.
Hope so far everything clear.
Yes. Yes, sir.
Next is IPv4. Usually you see in data link layer, or like the internet protocol, you see that IPv4 address, like IP address. That is actually, it's a protocol how we have to transmit the data, right? That is defined by this IPv4 protocol. Okay, so if you
Yes.
see here in the application layer, we usually talk about SMTP, FTP, TFTP, DNS, SNMP, BOOTP, all these things. In the transport layer, usually we talk about SCTP, TCP, UDP, all these things. But in the network layer, basically the protocol what we use is basically IPv4. Okay, that is a
Before.
protocol. That is a
Yes.
network layer protocol. IPv4 is an unreliable and connectionless datagram protocol. Huh? So when I say unreliable and connectionless, it's like it doesn't have the acknowledgement mechanism, right? Acknowledgement mechanism. Right? So
Yes.
best effort means the IPv4 provides no error control. Okay, it has error detection. How do we do the error detection? Using CRC.
Yes. Yes, sir.
Okay, and it doesn't have the flow control also. It is actually helpful for your internet protocol because, for instance, if you are like watching YouTube video, the basically like packets are sent from YouTube to you, right? So in that
Yes.
scenario, uh, if you are like not receiving the packets properly, then YouTube need not know that you are not receiving the packet properly and like resend the packets and all. That is a burden on the servers because millions of people will be using the YouTube. So in that scenario, you
Yes.
use the IPv4. Like it will be keep on broadcasting the packets. You will be just receiving it. Okay, so and it is no guarantee that you will receive that. You may have some errors
Yes.
or like glitches. Especially, you can take example of your internet.
Yes, sir.
Okay. If the reliability is important, then IPv4 must be paired with the reliable protocol such as TCP. Along with the TCP, if you include, then it will be reliable. We may have some
Yes.
acknowledgement and flow control also. Okay.
Yes.
So if you see here, basically like IPv4 packets, uh, 20 to 60 bytes of header will be there, followed by from 20th byte to 65536 bytes. That much data will be there.
Yes.
Okay. So
Yes.
coming to your header, you'll have version, header length, service, what kind of service you're providing, total length, identification bits, flags, fragmentation offset, time to live, protocol, source IP address, destination IP address, and like in between you will have like various route of those IP address. So such things will be there. So total 20 to 60 bytes of data will be.
Yes, sir.
Apart from that, all others are data, actual data. Header is 20 to 60 bytes, and up to 65,536 bytes of data you can. Okay.
Yes, sir.
So in the Ethernet, when you want to send, so usually you know that like all the data what we send, that is through Ethernet. When we send the data through Ethernet, you can see like we can correlate these two, right? It's same actually. It's like a version, header length, same thing actually they repeated. Type of service. So this like they mentioned like how it is actually looking. Apart from that, we will have TCP header, and application data is the actual data what you are sending.
Mhm.
See, it's same thing they
Yes.
are mentioning, the header and data, but this is like when you want to push through some Ethernet cable. So we'll also add Ethernet header, TCP header, and application data and Ethernet header. So
Sir,
that
Ethernet means internet.
no, Ethernet is the cable what you connect usually. So
Okay. Yes.
through that, you know that, right? Ethernet cable we connect, right? So for that, separate protocol is required.
Yes, sir.
That is a physical layer actually.
Yes.
Okay. And coming to the header format, the version of the IP protocol currently, whatever the IPv4 version we use, that is 4.
Yes, sir.
Okay, and header length is like how much length the datagram header it has. If you see here, it is like they are mentioning it is like 20 to 60 bytes, right? So here in the header length, what will happen? Like that exact address width, header width, you will mention.
Yes, sir.
Okay, this field is needed because the length of the header is variable. That's what like 20 to 65, right?
Yes, sir.
So if there is no option is given like 20 to 65, by default it will be 20 bytes. Okay.
Yes, sir.
When the option is given, then this will go up to 60 bytes.
60 minutes. Yes, sir.
And total length of the data is like total length of the packet minus length of the head. Here, if you see, it is actually that means this is header plus data, right?
Yes, sir.
Okay. So if somebody says total length is 65536 and header is 20 bytes. So in that case, if you want to find the data width, what do you do? 65536 minus 20.
6
That will
minus
give you how
20.
much. Yes, how much data is present in that IPv4 format. Clear?
Yes, sir. Yes, sir.
So next field, if you see here, that is service. That is actually of 8-bit, right?
Yes, sir.
So IETF has changed the interpretation and name of this AP. IETF is actually a organization which decides like what should be your standard. So
Yes.
this field previously called service, now it is actually called differentiated service. Previously, like it was calling this is just service. So precedence is a 3-bit subfield range from 000 in binary to 1111 in binary. Okay. So
Yes.
precedence defines the priority of datagram in issues such as congestion. So how it has to actually deal with congestion. So for that we give the priority. Okay. If the router is congested and need to be discarded some datagram, those datagram with the lowest precedence is discarded. So if you see here, if you give this any packets like lowest precedence, then that will be just discarded. So that like whichever the
Yes.
emergency data, important data is there, only those data will be sent. Okay.
Yes.
Okay. So here, like precedent, type of service, and unused. In the type of service is again, it's a 3-bit, right? 3-bit. No, precedence is 3-bit, 6 and 8, right? Okay, actually here one mistake is there. The 0th bit is unused. 4, 3, 2, 1. That is a type of keywords, type of service. Okay.
Service. Yes, sir.
Yeah, 4-bit, not 3-bit. So if it is like
Yes.
000, then normal. 001 minimize cost. 010 maximize reliability. 0100 maximize throughput. 1000 minimize delay.
Yes, sir.
Okay, so this is actually like what we do, right? So I mean, it basically based on this algorithm, your overall packet structure, everything will be formed. I mean, whether it will be discarded or saved, everything will be decided. Okay.
Yes.
So differentiated service in this interpretation, the first 6 bits make up the code point subfield, and last 2 bits are not used.
Not used.
And it's like in the new field they are saying. So now if you see here, like last bit, if it is 0, that means internet. If it is 1 then LAN data. Then like if it is
Yes.
like not defined, OI, temporary and experimental, it is like not defined. So this way, code point, differentiate itself. Okay.
Yes.
The total length, this is an infield that defines the total length of the IPv4. This is actually clear, right? I mean, how much length is the IPv4?
Yes.
And identification, it used to identify the source host, like from where that packet generated. Okay. So the combination of
Yes.
identification and source IPv4 address must uniquely define the datagram and its levels at the source host. To guarantee uniqueness, the IPv6 IPv4 protocol uses a counter to label the datagram. The counter is initiated with a positive number. When the IPv4 protocol sends the datagram, it copies the current value of the counter to identification of field and increments the counter by 1. There is a counter, internal counter, so which identifies what is the current protocol. So I mean sequence number what we add, right? Okay.
Yes.
There is a fragmentation. This is a 3-bit field. The first bit is result. Second bit is called do not fragment bit. If its value is 1, then the mechanism must not fragment the datagram. If cannot pass the datagram through any available physical network, it discarded the datagram sent to ICM. So basically, fragmentation means, so you saw that like 64436 bytes, which we can send the data, right?
Yes.
And like for instance, like if you have any acknowledgement based mechanism, if you do not send the acknowledgement, then what will happen? Then the packet may drop, right? So I mean, see that entire 65536 packet what you see that may drop, correct? So for that purpose,
Yes.
what we have acknowledgement based mechanism. I mean, we have fragmentation. Fragmentation, what we do, we chop the packets into smaller chunks, so that
Yes.
if there is any issue, right? So we need not send the whole set of packets. Okay. So for that we have 3
Yes.
bits. Either it can be do not fragment and more fragments. So that decides whether we have the fragmentation or not. So based on that, uh, receiver can be eased that. So you can see here, right? So 0 to 1399, 1400 to 2799, 2800 to 399. So that way basically they fragment. Okay.
Yes, sir.
And if you see here, there is a used to control the maximum number of options distributed datagram, and we have something called protocol. What type of protocol we are using in IPv4? If it is 1, then it is ICMP. 2 means IGMP. 6 if it is like then TCP. 17 means UDP. 89 means OSF. So that basically defines what kind of protocol we are using. Okay. And
Yes.
checksum is again like we know that how to compute the CRC, right? That CRC field is
Yes.
updated with the checksum. And last two location, we'll have source location and destination. That means like from where it is generated that packet and where that packet is going. Clear?
Yes. Yes.
Okay. So this is a problem. So in IPv4 protocol, H length is 1000 in binary. how many bytes of options are being carried by this packet. So here 100 means 8 in decimal, right?
Yes.
Okay. So if it is 8, then if you want to find the number of header in that, right? So then it is 8 into 4. That is actually 32 bytes. So that's like
32.
whatever the hash length value is there, you have to multiply by 4. So 32 bytes are there.
Yes, sir.
Okay. So
Yes.
that is actually overall size. In that, like we know that like first 20 bytes are base header, the next 12 bytes are options. Like it can be like uh, options means it can be data also, it can be header also, because 20 to 60 bytes minimum it will be 20 bytes. Okay.
Yes, sir. Yes, sir.
MTU, maximum length of data to be encapsulated in the frame. Like how much data you have to encapsulate within an Ethernet modem or like anything. So they have standards. So if it is like hyper-channel protocol, 65536 is the maximum limitation. If it is ring token ring, initially we saw that token ring means how that architecture looks. So if that kind of protocol, then we can have 17114. If we are sending FDDI based protocol, then 45352 is the maximum. If we are using Ethernet, like in your PC and all, then they can
Yes, sir.
go maximum 1500. Point to point link, maximum 296.
Yes.
Hope options you understood like what is fixed part and like variable part. So options gives us a flexibility. So when I said like header was like from 20 to some 60, around 60, right? So that is the option
Yes.
for us. Like it can be varied.
Yes.
So ICMP protocol is actually again one more protocol. So it is basically to see the objective of that. This protocol has no error reporting or error correction. Basically, IP protocols, right, doesn't have error correction and error reporting. But in this method, right, what we do is basically we add a approach if something goes bad, how to handle that. Okay.
Yes, sir.
So if you see here, IP protocols are lacks of mechanism for host and the management queries. So host sometimes needs to determine if the router on another host is like live or not. So whatever the data we send, right? So it has to reach to the other end. Then what happens? It passes through some routers. So this basically helps us. ICMP protocol, right? It helps us to detect them. So ICMP messages are divided into two broad categories. One is like error reporting messages and query messages. Okay. The error reporting message
Yes.
reports problem that router or host may encounter. So in that case, like we will not be able to reach the destination. The query message which occurs in pairs so helps to host or network manager to get the specific information from the router and another host. For example, node can discover their neighbors. It is basically ICMP, right? It is if there is any error occurs, what to do, how to handle, or like basically if you want to report or like anything is down, how to handle that. So that it leads. Okay. So the general format of ICMP protocol involves like 8 bits, that is type, 8 bits code, then checksum, and like we have data and rest of the data. An ICMP message, an 8-bit header, and variable size data section. Although the general format of header is different from each message type, because like this can change from message to message. The first 4 bytes are all are common. So in this right, this rest of the header it may change, but first four byte is always common. Okay.
Yes.
The data section in the error message carries information from finding the original packet that had the error. So in query message, the data section carries the extra information based on the type of the query. So whatever the other end, right? If there is like whatever the data you send that has any error, then it will report. Okay. So in error reporting typing, we have various types. The error reporting, if you have destination is unreachable, that is one type of error. Source quench, time exceeded, parameter problem, redirection. These are the error usually you see. Whenever, for instance, like if internet connection fails, so this kind of errors you usually see.
Yes.
So no ICMP error message will be generated in the response of datagram carrying an ICMP message. So if it is like datagram is carrying ICMP error message, if that itself has error, then another error message will not be generated. So then no ICMP message will be generated for a fragmented datagram. It is not a first fragment. If that is like not first fragment, right? Then also it will not be generated. If the data has multicast address, then also it will not generate. So data having, if it is having special address like 127.0.0.0.0.0, this kind of message, it will not generate ICMP error message. So this is like same thing they explained again. Whatever the header we. So you can see like some of the types of error, like destination is unreachable, time exceeded. So these are all the errors you usually see in the internet also, right? Whenever you doing some
Yes.
transaction, if the time exceeded, you will see that the time exceeded. Server is not reachable. That kind of usually, right?
Yes, sir.
So redirection. So I mean, if you want to like you have server, you want to redirect from that server to the that kind of mechanism also is called packet uh, switching.
Yes.
You can see the redirection. So you have a LAN and data IP packet sent. So this way it's sent here, and it may be like send redirected way also. Okay.
Yes.
So along with the ICMP messages, so we will also have some kind of query messages. Okay. So in the query messages, it's something like if you want to request, if you want to request the timestamp, if you want to ask for the address, so if you want to get some router details, so these will be answered in the query messages. So you have to send through query messages. For instance, like echo request and request. So if you want to check any server is up or not, right? So you will be sending some request, so it will echo the data, right?
Yes.
Okay. So usually we encapsulate ICMP data with the headers actually, with the query messages. So that like whenever we want to get some response, uh, we will get that. I mean, with the ICMP message, we'll get the response. Okay.
Yes, sir.
So whenever I want to send some data to a particular destination, so I will know the IP address. So we saw that like within that IP address also we will have various masks, right? So I mean, it has to return. It has to return to the specific location, right? So in the protocol, we also request the address mask where we have to write exact. So that is actually address mask request. Okay. Router
Yes.
solicitation and advertisement. So if the host want to send some data to a host in the another network, so we need to know the address of the routers connected to its own network, right? So the host also must know if the routers are alive or functioning. So the router solicitation or router advertisement message can help this situation. So it's like all the routers, right? It will be keep broadcasting the signals. So that like it's advertising. So your network will know like what are like its corresponding like neighbor routers, how the data has been. So rough idea we will get in host. So for that, you will get that broadcast messages. Okay.
Yes, sir.
So this checksum calculation, you know, right? So basically, we will be XORing everything.
Yes, sir.
So we have already discussed many checksum calculations. So this like I just skip this part. Okay, you can take this one. So in an IP packet, the value of H len is 5, like they're saying in hexa, and the value of total packet length field is 28. How many bytes of data are being carried by this packet? So you know H length is 5, correct?
Mm.
So then
Yes, sir.
the total number of bytes in header is 5 into 4. We have to multiply by 4, right?
Fine.
The total
Yes,
length is 40 bytes, correct?
40.
So this
Yes.
28 they are mentioning in hexa, correct? So if
Mm.
28 in hexa, then it means 40. Okay, 5 into 40, 20 bytes are header. Total length is 40, right?
40.
Because this 28 into 28 you have to convert into decimal. So then data, if you want to find, that is actually 40 minus 20 will give you data set. Clear?
Yes.
The delivery refers to the way packet handled by the underlying network. So where the packet has to travel through various networks, right? So how it is delivered to the other end. So that basically defined by delivery. We have
Yes.
various methods of delivery. One is direct delivery, indirect delivery. In direct delivery, the final destination packet is host connected to the same physical network. So I mean, it is like within the network, like within the ACP fiber net, or like within the LAN, that kind of thing. So indirect
Yes.
delivery, if you see here, direct delivery is basically within that like network, same computer, like host, it is like present in the same network, like in your home network or your college. So indirect delivery
Mm.
is not directly within the network. So if you see here, like it has to pass through router.
Router.
Correct?
Yes. Yes, sir.
So forwarding, actually, I was to server forward. Want to forward managers. So we have like a next hop method and route method. So if you see here, this particular the data hopping, right? The identification network. This way actually it will happen. Like you can see the table. So in the next hop or like routing based on uh, route method or next hop method. So if you see here in the routing method, host B, R1, R2, host B. This way, right? From host A, it will go to R1, R2, then host B. In the
Mm.
hop
Yes.
method, actually host B is the final one. So it will go to R1, then it will hop to R2, then it will hop to the network. So that actually
Net.
hopping will be there. But here our end aim is this. So in one shot itself it will hop and it will go. But in this case, like we are bothered like very next packet only. So we are not bothered about whole thing. Hope you're
Mm.
getting it.
Yes, sir.
Next is actually network specific and host specific. So network specific means actually the network provider or network vendor will be handling all the errors. He will be knowing where the nodes are located. But whereas host specific, host have to say that like where it is located. So always the network one is actually easier. I mean, if you see here, uh, routing table for the host is based on host specific method. So destination A next hop is R1, B is next hop is R1, like that. So in the routing table method, so destination is N2, next hopping is R1. So
Yes.
here actually step by step hopping kind of thing, right? First one. So next one is actually end-to-end planning. Okay.
Yes.
So this meeting, I mean, the Zoom, it will end within like 1 or 2 minutes. But now basically like we have to focus on this routing techniques. Okay, routing techniques are there, route calculation and all. So this I need one class. Okay.
Yes.
Apart from that, we look into like what else. Then the problems also. You shared that problem, right? I'll solve in the next class. I just need to check
Yes.
that.
Yes.
Can you resend that unit 5?
Yes, sir.
So next week, which are the days you can attend the session?
I'll
Every day you
attend,
can
sir,
attend.
like till. Yes, sir.
Daily you can attend, right? Okay.
Yes. Friday
So
attend,
morning,
sir.
okay, morning and evening both we will plan. Tomorrow morning around 7 o'clock, is it possible?
Yes, sir.
Tomorrow morning, please block your calendar. So tomorrow morning 7 o'clock we will plan. Okay.
Yes, sir.
In one stretch, usually I will not take because like I'll be having like other sessions in those. I'll plan something like one session morning, one session in the evening. That way will.
Yes, sir.
My session may end, so please actually tomorrow 7 o'clock we will discuss. Okay.
Yes, yes, sir.
Okay. Thanks.